Hey folks, welcome back. This is the final video on the Zenith 808. A couple videos back I showed the derusting process, so I cleaned up the remainder of the chassis right around the IF coils that you see here on this edge. And again, this was after removing the tuning condenser and the power transformer, as you can see. So, the chassis overall looks like it cleaned up pretty well. Still a little bit of pitting, but nothing really to be concerned about. After completing the rust removal, I'm actually switching products here using a Renaissance microcrystalline wax polish on the chassis itself to be used as a rust inhibitor. Time will tell if it really holds up. I'd mentioned I'd already removed the tuning condenser and it had a lot of rust, so again I relied on the Evapco rust. Save your little Blue Bunny frozen yogurt containers. They work great for the derusting projects. After letting that sit for about, I think 3 to 4 days, I actually removed it, threw it in the ultrasonic cleaner, and then I used my old TSP or trisodium phosphate to actually finish the cleaning. Here are just a few more photos after running it through the cycle probably 8, 9, 10 times, and then washing the tuning condenser clean with warm water. As you can see here in the pictures, the old tuning condenser cleaned up nicely, as well as the associated hardware. Next, I moved on to applying some high quality gear oil. I love the LaBelle's product here that I'm showing, so I used their gear oil followed by, some grease as well down in the ball bearings. It's important to put the oil in first and then apply the grease, and the grease helps hold the oil back on the bearings itself. But again, you can see me moving to various contact points on the old tuning condenser where that center shaft piece makes contact with metal, and this thing was flowed freely once I got done. As I mentioned earlier, it's important to go from stage to stage here, and again, anywhere that center shaft makes contact with any stationary part, just to give it just a small drop. And believe me, with this particular product, you don't need much at all, just a little drop or so. Spend some time after you put the product on and rotate the tuning condenser back and forth, and again, the results for me were spectacular. On my last 2 restorations, I've done something just a little bit different. On the tuning condenser and associated hardware, I actually used the Piclux 20 product. Used that small little spritzer that you see there to the right. After applying that product on, I actually used forced air, dried the product on, and it created a really, really nice barrier, I think, to act as the rust inhibitor for years to come. I'm one that believes in repurposing your old hardware where you can and where it makes sense to do so. You already have your rust removal products on hand, so when it makes sense to do so, I recommend you do the same. As you can see here in the photos that I'm sharing, the wire that actually leaves the IF can and the RF coil is in bad shape, so I'm just taking time here to slip a piece of heat shrink over the top of that. Remove those grid caps, resolder those on, and just make sure they're good to go. Now again, I decided not to open up a can because I could actually look down in the can itself, and it appeared the wiring itself was in great shape, and the breaks themselves in the wire, or the protective covering, the cloth over the wire, was right at the location where the wire protruded through the can. So if I have any additional problems in the future, then I'll look at just opening the can and pulling it from the chassis. But why go through that if I can make this simple repair? So here I am replacing the wiring as well from the tuning condenser that runs back to the detector coil and that jumper that goes over to the first detector 6A7 tube. In addition, you can see these grounding points. I think there's 3 or 4 grounding points here that tie back to the underneath side of the chassis. My high wattage soldering iron decided to go out, so I've got those soldered underneath, but I'm going to have to touch them back up. I just didn't have enough heat to really do a good job, so I've probably got a cold solder joint at those 3 locations, so I'll need to remove the tubes and then get my soldering iron wedged underneath here and just apply some better heat. Make sure I've got some nice grounding connections. Here's just a quick close-up of the grommets that I actually use, the rubber grommets that sit between the chassis and the tuning condenser. With the new grommets in place, it did create some nice stability here for the tuning condenser. And again, applying that Labelle's product on the shaft, everything really rotates nice and smooth. Again, here are a couple photos of me with the power transformer physically reattached back to the chassis itself after the derusting and painting. And it sets up nice here to get started on the electrical restoration and get it tied back in. So here are just a few more photos. Again, I've got the transformer reinstalled again as stated. You'll notice these red leads coming out, or the heat shrink over it. I had just a couple small fractures in the wiring, and as I was tying everything in, I decided, let's go ahead and get these things well protected. So I just slipped some heat shrink over the top of them just to prevent any type of future problems. Now it's time to go ahead and get those electrolytic can capacitors restuffed, and I actually only restuffed one. I put all 3 electrolytics inside one can. One thing you'll note I did different here, I used my tubing cutters, which I really love this technique, but I used painter's tape and created a real nice lane for the blade itself to travel, and I got a superb cut. This is actually much better than my last cut that I made, and I'll probably continue to use this process going forward because I don't think I could actually do any better. You can see here in the photos that I'm sharing how clean the cut lines are. Just a few photos I thought was worthy of sharing. It's just the innards of the old electrolytic can capacitor here with the screening or mesh material on the exterior side that was riding around the inside of the can itself. And again, I'm just showing these for reference out there for folks that enjoy seeing these type of things. Just a few more photos again of the can and the cut that I made, and again you can see the cut line or where I'll be able to put these two back together, and I'll show the technique for doing that here in just a few minutes. Next up was actually just restuffing this old cap, and one thing that you'll notice here on this schematic that this particular capacitor is isolated from the chassis, so that's important to note out there. If you're a restorer, pay very close attention to the schematic. Don't assume that that negative connection always goes to the chassis ground itself. You can see here you've got these protective pieces of material that separate the electrolytic can itself from the chassis. So please take note of that out there for folks that are doing these restorations. Here you can see me taking a terminal strip, increasing the size there of the mounting location, just using a file, and I can actually now mount that back to the same hardware where the power transformer comes up. Again, that's just an additional tie-in point that I need here after restuffing the electrolytic cans. As you can see, the process here, which I've shown before, that I'm actually taking. Additional photos here, getting the caps ready to be restuffed into the existing can, and again you can see some of the lead wire dressing coming up from the can back over to the one terminal strip, and as well, once I got the other electrolytic can back in, I actually used one of the terminal lugs on it, split another terminal strip and soldered it to it, and created another very, very nice tie-in point there to be used for the connections. Going back to the tuning condenser here again, I'm just doing some derusting of the screws as well as cleaning up these pieces of mica. Don't be concerned if these mica pieces break. I know a lot of people freak out about it, but the dielectric constants for mica is probably 4 to 9, and there's a lot of modern day plastics that you can use to slip back up underneath there and get the same end result. So much time is spent really on the mechanical aspects of the radio. I can say in some cases it's more than 50% of my time doing, or 60% doing the mechanical side versus the electrical. But here again, just some photos of the recapping as well as replacing out of tolerance resistors. I started from the power transformer, work my way back to the power tube section, through the detector AVC IF, the oscillator section, back over to the RF section itself. So again, I'm just sharing some photos here of the recapping process. One thing that's really noteworthy, when I started looking at the caps closer, I could tell some of these definitely had been replaced at some point in time. In addition, I don't think I've ever done a restoration that so many of the resistors were out of tolerance. I'm talking by, 150, 160% out of tolerance. I mean, it was crazy some of the readings I was getting. I thought my multimeter, had failed me at first, but, only a few of the resistors fell within, plus or minus 20%, but most of the values were on the high side, which is typical, but I don't think I've ever seen any, so high. The component lead dressing is also important to me. I mean, aesthetically it's pleasing, but I also try to make sure all the values are facing me, and I really take a lot of pride in this particular part of the restoration. I think it's just as important as the electrical tie-in points themselves. Here are just a few more photos again of my shop and some of the equipment that I use. Again, I've got the frequency counter, RF audio generators, sweep generators, high quality multimeters, another sweep generator, oscilloscope, and I've got probably another 5 or 6 other test pieces of equipment that I don't have there in the shot. But anyway, you can see me here in the picture-in-picture. I'm actually just kind of working my way through the alignment process. Again, that was starting with the IF alignments and then doing the wave trap pattern that was underneath, and then moving into the alignment on the shortwave band or at 15,000 kilocycles, and then finishing up everything, adjusting the broadcast oscillator as well as the RF and first detector trimmers, and I was done. This thing aligned to the T. I don't think I've ever had a dial indicator be so close. It's now time to put the electrolytic can back together, and I typically use a thick plastic material. You can just pick up this thick plastic at your hobby shops, and typically I'll layer two wraps or more. In this case, I think I ended up using about 1.5 or so, and that was just due to the amount of room I had inside the capacitor. But I just cut out a really nice sleeve, slip it inside the capacitor to the correct length, and then push it back down into the piece closest to the chassis, and it does an okay job. This thing shouldn't get banged around a lot. If anybody needs to get back in it, they can just pop that right off and have access there directly to the capacitors. One thing else too, I'm not sure if you noticed, I put some hot glue back on the trimmer adjustments on the capacitor itself, and I'll do that in a lot of cases. Folks may frown on that. Here are just a couple photos again of me taking these goat tube shields and getting those cleaned up and derusted. They turned out fantastic. I still need to clean up this wiring that you can see. I've got a few housekeeping things, so I've got to decide if I'm going to replace this wire in total from the speaker, as well as put more of an authentic AC power cord back on. So again, thanks for watching, and I appreciate my new subscribers out there as well.